In ancient Greek mythology, there is a tale known as Phaethon and the Sun. It centers around Phaethon, the young son of Helios, the sun god, who daily rode his chariot across the sky, bringing warmth and energy to Earth. Phaethon, eager to prove his divine heritage, visits his father's temple. After confirming their relationship, Helios grants his son any wish he desires. Rashly, Phaethon asks to drive his father's chariot across the sky. Helios tries to dissuade him, but is bound by his promise, and reluctantly hands over the reins to the insistent Phaethon. Immediately after taking off, Phaethon loses control of the chariot. Veering off course, it hurtles recklessly through the sky, getting dangerously close to the ground and scorching the Earth's surface. According to the Greeks, this is when Libya's hills were turned into desert, the Nile's flow retreated, and the skin of the Ethiopian people darkened. Although this story is a myth, it subtly hints at a significant fact. The deserts of Libya and other Saharan regions were not always the barren wastelands they are today. Earth is an incredibly dynamic planet, more than we often realize. Its tectonic plates, weather patterns, and seasons are in a state of constant change, and its orientation in space is far from stable. Due to Earth's slightly oblate shape and the gravitational influence of other planets in our solar system, its orbit, tilt, and wobble are continuously fluctuating over time. Every 100,000 years, Earth's orbit transitions between a nearly circular and a slightly elliptical shape. Every 41,000 years, the tilt of Earth's axis shifts between 22.1 and 24.5 degrees. Additionally, every 26,000 years, Earth's axis completes a full wobble cycle. These three fluctuations are known as the Milankovitch cycles, named after Serbian mathematician Milutin Milankovic, who pioneered their study in the early 20th century. He discovered that these cycles, by affecting the amount and distribution of sunlight on Earth, have a profound impact on the planet's long-term climate. Meanwhile, the extra rainfall accumulated in the region's geographic depressions to form lakes, some of which were enormous. These included lakes Megafezan and Megachad in modern-day Libya, Algeria, and Chad. Lake Megachad once covered 360,000 square kilometers, making it the largest freshwater lake in the world at the time, slightly smaller than today's Caspian Sea. These lakes, along with now non-existent river networks, trapped water in the Sahara's interior, allowing vegetation to be sustained year-round. As a result, nearly the entire Sahara Desert transformed into a lush green region just 10,000 years ago. Although this might seem unbelievable, there is ample evidence to support it. For instance, the more eccentric Earth's orbit is, the greater the difference in the lengths of the seasons, and the more extreme the tilt, the more severe the seasons become. However, perhaps the most intriguing effect arises from the interaction between Earth's wobble and its orbit. Currently, Earth reaches its perihelion, or closest point to the Sun, in early January. As a result, Earth receives a bit more sunlight during the Northern Hemisphere's winter and the Southern Hemisphere's summer. Approximately 13,000 years ago, when Earth's wobble was at the opposite end of its cycle, this situation was reversed. Earth received additional sunlight during the Northern Hemisphere's summer and the Southern Hemisphere's winter. This increase in summer radiation over North Africa was around 7% higher than it is today. While this difference may seem minor, it had a massive impact on the region's climate. With more energy reaching the surface, the air heated up and rose higher, creating a low-pressure zone that in turn drew moist air from the surrounding Atlantic. This moist air then rose and cooled, condensing into rain clouds that showered the Sahara. Climate models have shown that this process increased rainfall in North Africa by 17% to 50% compared to today. This increased rainfall allowed for more vegetation growth along the coasts and southern edges of the Sahara. Vegetation, which is darker than sand and therefore absorbs more energy, also helps transfer underground moisture into the atmosphere through transpiration, creating a positive feedback loop that ultimately spread vegetation across North Africa. All across the Sahara, in areas now dominated by sand and rock, ancient people's rock art depicts detailed scenes of gazelles, elephants, rhinos, hippos, giraffes, and other animals. In the Tenere Desert in Niger, which is currently inhospitable to life, archaeologists have found hundreds of human graves along with the remains of land animals, large fish, and crocodiles. In Libya and Algeria, ancient riverbeds have been discovered with evidence of human habitation. And in Chad, evidence of Lake Megachad's ancient shores can be seen through sand spits and beach ridges. Perhaps the most direct evidence comes from sediment cores sampled from underwater off the African coast, used to study Saharan dust flux, the amount of sand blown off the African continent into the ocean. These cores reveal that between 10,000 and 5,000 years ago, the amount of sand blowing off Africa was much lower than today, indicating more moisture and plant life. Additionally, pollen trapped in these cores shows increases in grasses and sedges during this period. All this evidence has led scientists to conclude that between 12,000 and 5,000 years ago, the Sahara was vastly different from today, covered in grasslands, waterways, forests, and teeming with animals and ancient human settlements. However, starting around 6,000 years ago, this green world rapidly receded. With the reversal of the orbital cycles, the same feedback loop that made the Sahara green turned it back into the desert we know today. Human activities, such as cattle overgrazing and fireland management techniques, likely further strained the region's ecology. Within a few centuries, the lakes dried up, plant life retreated south, and animals and people followed. Despite the Sahara's current arid state, it is almost certain that another humid period will occur in the future. Over the past several million years, there is evidence of over 230 such green periods, aligning with Earth's wobble cycle. When Earth's wobble reverses again in about 13,000 years, researchers expect the Sahara to turn green once more. If human civilization is still thriving, this development will significantly impact global geopolitics. The barren deserts of Algeria, Libya, Egypt, Mauritania, Mali, Niger, Chad, and Sudan will become fertile, opening up new areas for settlement and likely leading to substantial population growth. Rivers will flow again, and lakes will refill, making North Africa a new global hotspot, with new cities and potentially new countries emerging. However, this is far into the future, and there is no guarantee that human civilization will still exist in its current form. To overcome this time constraint, researchers have proposed ways to artificially green the Sahara, possibly even within the next few centuries. The first method is already happening. Unlike the gradual climate changes caused by the Milankovitch cycles, Earth's climate is currently undergoing a rapid transformation due to human-induced greenhouse gas emissions. These emissions are trapping more energy in Earth's atmosphere and on its surface. Models suggest that this increased energy could trigger the same processes that brought more rainfall to North Africa 10,000 years ago, expanding vegetation across the region. While this is exciting, heating the entire Earth for the sake of more plants in the Sahara is not advisable. There are less harmful ways to achieve the same goal, and one of the most promising would also help combat climate change. By installing large-scale solar and wind farms in the Sahara, which increase surface roughness and darken the terrain, more energy would be absorbed and precipitation would rise. In the near future, we could harness renewable energy while triggering the positive feedback loop and bringing back the green Sahara. If you enjoyed this video, subscribe to CosMik Space for more videos like this one. Thank you for watching, and see you next time.